In 7.5, this is the last section in Chapter 7, which means after this section, there's nothing new and everything is getting you ready for the test. This whole chapter has been about triangles and radicals and Pythagorean theorems, special right triangles, and this thing called trigonometry, the SOHCAHTOA stuff that you learned in 7.3 and 7.4. This is not going to change it. What this is going to do, this is going to give you an extra element in which you can use trigonometry to solve problems. So the first thing that we're going to do is now we're going to deal with real life situations in which there's going to be something called the angle of elevation. That's how far up you're going from horizontal up, and or from horizontal down is the angle of depression. If a word problem says, what is this an angle of elevation or depression, you have to decide, is the object going from horizontal up or is it going from horizontal down? The other thing is that even though you see this dog and he's looking up at the bird for an angle of elevation, if there was some bug on the ground and the dog was looking down at the bug, that can also be an angle of depression. Angle of depression as well. So even though you see a shape that's sort of in the middle, when they look up, think of it as elevation. When they look down, it's the angle of depression, and it's always from horizontal. I say that because if you ever get told that there is an angle of depression or something along those lines, and most people want to draw it straight down, this angle is not the angle of depression. The angle of depression is from the level part to the object. This is the angle of depression, not from the tree. It's from horizontal down. I want to say that. Same with the angle of elevation. It's not the angle straight up. It's not this angle. It's the angle from horizontal up, or from the ground up. I'm hoping that makes sense. And these two angles are always going to be congruent to each other. Why are they congruent? Because of the alternate interior angles theorem. If you're ever dealing with a proof, they're congruent by that property. And then the last few things that we have, what we did in 7.3 and 7.4, that's how we're going to solve the problems in 7.5. The last thing that I have here, it says there is a relationship between the sine of A and the cosine of B. The sine of A of a triangle, the acute angle of a triangle, right triangle, the sine of this A, let's call it A, and the cosine of B, the other angle, there's a relationship between those two things. If I'm thinking about the sine of A, the O and the H, and I'm thinking about the cosine of B, the A and the H, there's a relationship between those things. Let me think about that. The O over H and the A over H, except the O and the A are in the exact same spot as each other. That should kind of give you a hint as to what that relationship is. Matter of fact, since you have your notes out, let's make sure that you guys know this in your notes. The sine of A is always going to be equal to the cosine of B. We're going to put that there, and I'm hoping you can see it in problems 9 through 16. So with that being said, I have several examples picked out for you. Number 1, number 6, number 9 and 11, and 22. So let's go ahead and do some problems together. If you want to do these in the worksheet, you are welcome to do so. There's a person on a cliff. There's a person in a boat. There is a fish, alligator. I can't tell what that is. Something underneath the water. Okay? Which are angles of elevation? If you know which angles are angles of elevation, say the angles out loud.
2 and 4.
If you said 2 and 4, you are correct. Which are angles of depression? If you know which angles are angles of depression, please say those numbers out loud.
3.
I agree. The last question on number 1 says, if the horizontal lines are parallel, which pairs of angles must be congruent? The way that I would want you to write these is that 1 and 2 must be congruent. Angle 1 is congruent to angle 2. And 3 and 4 have to be congruent to each other. But not necessarily does 2 relate to 3 or does 3 relate to 1 at all. It's just the 3 and 4 and the 1 and 2. Those ones are the pairs. Those are the ones that are opposite of each other. Or I should say they have the same transversal. They're linked by the same transversal. The next example that I have for you is a word problem. In this section, you can expect to see a lot more word problems. The directions say sketch the figure, use trigonometry to solve, express each length to the nearest tenth, and each angle to the nearest whole degree. Number 6 says, a person in a lighthouse is 22 meters above sea level, sights a buoy in the water. If the angle of depression to the buoy is 25 degrees, how far from the base of the lighthouse is the buoy? So imagine there's a person in a lighthouse. There's a door. And that's the water. Water. And out here there is a buoy. What does a buoy look like? Let's go with this and put a little bell up here. Ping, like that. The person in the lighthouse is 22 meters above sea level. 22 meters. 22 meters. And sights a buoy in the water. Oh, there's a buoy right there. Right there. If the angle of depression to the buoy is 25 degrees, this is where I tell you a lot of students make mistakes. The 25 degrees does not go here. The 25 degrees is always from eye level or from horizontal. So imagine that there is this horizontal line right there. And from horizontal down is 25 degrees. That's the angle of depression. I cannot tell you how many times students get that one wrong just because they put the 25 in the wrong spot. From horizontal down is 25 degrees, and that angle of depression is the same thing as the angle of elevation from the buoy. Up. So sometimes I'll put the 25 degrees over here, and it makes a whole lot more sense for me to do the problem this way. Otherwise, what you have to do is you have to draw this and like this and draw another right triangle. Otherwise, you can use this triangle right here. This right triangle. 25 degrees. So now what I'm going to do, how far from the base of the lighthouse is the buoy? So what they want to know is this distance here, x. All you have to do is figure out this is the OH or A. The x is that OH or A. And that should let you know which one you're going to use. There's SO, which has an O and H. There's a KA, which has an A and H. And then there's a TOA that has an O and an A. Which one are we going to use? Yep. And I told this to a student in class today. If you are just punching things into your calculator, how are you supposed to get partial credit if you mess up? Here's how you get partial credit. Always write down the equation that you are punching into your calculator. The tangent of 25 degrees is equal to 22 OA over x. And that way I can see what you're plugging into the calculator. If you have it set up and you forget to do the, x is in the bottom. We got to flip it and flip it. X over 22. If I flip the right side, I have to flip the left side. 1 over tangent of 25 degrees. Instead of dividing by 22, we can then multiply by 22. And so what we can plug in is 22 divided by the tangent of 25 degrees. Making sure I'm in degree mode. This is a distance nearest tenth. That was 22 meters. 47.2 meters is our answer. Kind of interesting, right? You could actually be inside something, look and see something and measure the degree, and you could figure out exactly how far away it is. That's trig. That's how they calculate a lot of the stuff in the old days before lasers and other things like that. Next example. 9 through 14. Find the value of each trig function in reduced fraction form. The sine of A. I go to A. The sine is the O over H. I need to know which one's O and which one's H. I'm going to put my work over here and put my final answer. O is 2 root 3 over 4. Outside reduces with outside. Divide by 2. Divide by 2. I'm getting root 3 over 2. That's what it is in reduced fraction form. The cosine of B is the A over H. 2 root 3 over 4. And guess what? It's going to be the same thing. The whole idea behind what they're going to be asking you questions on over on 9 through 11 is you can see that the sine of A, the sine of this side, is going to be equal to the cosine of this side. The two acute angles, the sine and cosine, they are equivalent to each other every single time. It's kind of a neat thing. So look at those kind of questions on 9 through 14. The last example that I have for you is 22. And it says this: solve for x using trig or other mathematical methods. Okay. So we need to figure out x, and I don't know anything about this distance or that distance. The only thing I have is this distance here. So what I'm going to have to do is I'm going to have to figure out what things are to get to this distance over here. Like I need to know what this red line is. Why do I need the red line? Because I need something that's in this triangle to be figured out so that I can figure out what's going on in this triangle. This is a 30, 60, 90 degree triangle. Across from the 30 is S. Across from the 90 is 2S. Across from the 60 is S root 3. I start off with that. And then what I do is, since 40 is equal to 2S, I can figure out, since 40 is equal to 2S, that S has to be equal to 20. That means this red line over here is 20 units long. Let me put 20 right there. I could put it down here that this is 20 root 3, but that's not going to help me. And now I have enough information in this right triangle to figure everything out. I have an opposite, and I have a hypotenuse. I know which trig function to use. Which one has the O and the H? Sine. The sine of what angle? The sine of angle 50 degrees is equal to the opposite over the hypotenuse. If the variable's in the bottom, it is. we need to flip it. When you flip the right side, you have to flip the left side. 1 over sine of 50 degrees. And when your x is in the top, then you just do the opposite and divided by 20. It's multiplied by 20. What we'll plug into our calculator is the 20 divided by the sine of 50 degrees. We need to go to the nearest tenth for a distance. It's about 26.1 is what I'm getting. And I'm going to stop your notes right there.